Hello everyone, welcome to eduxcite Classes. My name is Monit. Continuing with the last video, we are continuing the series of A.1, and in this video we will be starting with A.1.2 suvat equations. Requesting you to please download the worksheet. The link is given in the description, and solve this worksheet before watching this video, or even you can solve with me. I will give you time for pausing the video. You can solve the question and then you can play to check your answers. The annotations, whatever I will be doing, you can download the PDF or the marking scheme. The link is again given in the description. Okay. Small request to please share this video as much as you can with your friends, classmates and everyone, so that it can reaches to the masses. That is the only purpose of making the series topic wise question for the new syllabus IBDP Physics. So let us start without wasting time. Okay, so this is the equations that are given to you in your data booklet. You can use these equations which are for the A.1 kinematics. These are nothing but called as the suvat equations. Okay, now the very first question you can pause and solve. Okay, so the A part, this is the car which is starting from rest, so 0, and the acceleration is uniform 18 meter per second square. This is per square. Okay. Now we have to find out its speed after 3 seconds. So the time we have to find out after 3 seconds, so we will use v equals to u plus at, the first equation, right? So the velocity we have to find out, or the speed, initial velocity is 0, acceleration is 18, time is 3. So velocity is nothing but 54 meter per second. I hope it is quite clear. Now the B part, calculate how far it travels in this time. Now in this 3 seconds we have to find out how far the car has traveled. So we can use v square equals to u square plus 2as also to find out. S stands for the displacement, or you can use st equals to ut plus half at square. So using s equals to ut plus half at square, this becomes 0 because the initial velocity is 0. So s is equals to half times 18 times 3 square. So when you solve this, this will be 9 into 9, that is nothing but 81 meter. So the displacement for this, you can use your calculator if you want. And now the C part, it continues to accelerate. We have to find out its velocity after it has traveled a distance of 200 meter from the start, from the beginning. So we have to find out velocity. So I am using v square equals to u square plus 2as. So v square we have to find out, this again becomes 0, which is 2 times 18 times s we have to find out for 200 meter. Now you can do the calculations. So v will be equals to, you can do the calculation on your own. So the answer will be 84.85. I have already done the calculations, or rounding off it can be 85 meter per second. So this will be the answer for the question number 1. Now just check for the question number 2. Pause the video and solve. Okay. So the aircraft, it is taking off and starting from rest. Okay, so this will take off and it is starting from rest, and it is uniformly accelerate to a speed of 100 km per hour. So this will be the final speed before it takes off. Okay, and the time for this is 16 seconds is given to us. Now we are supposed to find out the acceleration in meter per second square. So the first and the foremost is this speed. This speed has to be converted into meter per second. So how we convert any speed, let us say x kilometer per hour, to let us say y meter per second. So this is nothing but, simply to convert we can say x times 1000. So x times 1000, and per hour the conversion into second will be 3600. Okay, so this will give you x times 5 by 80, which will be your y. So simply if it is 100, so I can say the velocity, final velocity will be 100 times 5 by 80. So I have done the calculation already, which is equals to 27.78 meter per second, Okay, so and the initial velocity is 0. So the time is already given. So what we can do for the acceleration is v minus u by t. So v is 27.78 minus 0 over time, which is 16 second. So if you solve this, you will get 1.736 meter per second square, or in simply you can say acceleration is equals to 1.7 meter per second square. So this you can solve for the A part, right? Now the B part is quite easier. I am solving the B part here. Calculate the minimum length of the runway. Now converting to the 100 nearest 100 meter, assuming that the acceleration is constant. So minimum length required, we can use v square equals to u square plus 2as, right? And initial velocity is 0. S we have to find out. Final velocity is we have already converted into this. So this will be 27.78 square equals to 2 times of acceleration. This is 0. Initial velocity is 0. Acceleration is, you can take 1.736 divided by s. So if you calculate for this s, you will get 1388.97 meter. So s can be rounded off to the nearest 100 meter is 1400 meter, which should be the minimum length of the runway to achieve the velocity using the given acceleration. Okay. So the answer for question number 2 are these two answers. I hope it is quite clear. If you have any doubt related to any numerical or the problem, just comment below. I will try my level best to explain you again. Okay, so just comment it below. Now just pause for question number 3 and solve. Okay. So this is the car traveling at a constant speed, let us say 21 meter per second, and this is initial velocity is 0, and as this car, police see this car passing by, it started with a uniform acceleration of 4 meter per second square for 8 seconds, and then it attains the velocity v, and then it moves with the same constant velocity, right? So first of all, we have to find out when did the two cars have the same velocity, and we know that this is moving with the same. So we have to find out when the police car will have a velocity of 21. So for simple, we can do is like I can solve it here for the A part. So 21 is the v, u is 0 plus I am using v equals to u plus at, right? Acceleration is given to us as 4 and time we have to find out. So let us say t. So because why I am taking considering t, because we know that the maximum velocity of this police will be u plus at. A is 4, time for it is 8. So it will accelerate till it reaches a speed of 32 meter per second. And 30 before and during the acceleration only, this police car will attain a speed of 21, because 32 is greater than 21, right? So therefore I assume a time t which should be less than 8. So let us check. So t will be 21 by 4, which is nothing but equals to, you can use your calculator, 5.25 second, rounding off to 2sf, it will be 5.3 second. Okay, so this is your answer for the A part. Now you can solve for the B also. Determine if the police car has overtaken the car after 10 seconds. So let me solve it at the bottom. Okay, now we have to check after 10 seconds does this police car has overtaken this car or not, right? So what we can do is we can find out the distance covered by the car and the distance covered by the police car, and then we can compare which one is if the police car distance or the displacement is greater than this car, it means it has overtaken the car, otherwise we can say it is not. So just calculate the distance. So for car, as displacement for car is speed into time, which is 21. Okay, and the time for which we have to consider is 10 seconds, right? So 21 into 10. So this will be equals to 210. meters. Similarly, for the police car, it will be, again, now you have to understood, for the first 8 seconds it is accelerating and then it is moving with the same velocity for the next 2 seconds. So what we can do is, first we have to find out the velocity after 8 seconds for the car, which is nothing but, I know that, which is u is 0 plus acceleration is 4, time is 8. So that will be 32 meter per second. So for the first 8 seconds, the displacement, we will use the suvat equation, and for the next 2 seconds it will be simply speed into time. So the total displacement in the first 10 seconds for the police car will be, I will use ut plus half at square for the first 8 seconds, and then speed into time for the next 2 seconds. So for some, this will be 0, right? So half, or we have already calculated, I think so, no, okay, so we can do half times acceleration is how much, 4 into time is 8 square, this is for the accelerated version, and then 32 into 2. So if you solve for this, you will get displacement as, yeah, so this is for 210 and this you will get for 128. This will be equals to SP car is equals to 128 plus 32 into 2, 64, that is equals to 192 meter. So now you can compare the values, right? This is 192 meter and this is 210 meter. So we can say no, the police car does not overtake the car. Okay, simply. Now the C part, by equating the two equations for the same distance at the same time, determine exactly when the police car overtakes the other car. Now this is quite interesting. We have to find out when the police car will overtake the other car, and that is, here they have given the hint that they will be at the same distance, but this you have to remember that it will overtake only when the displacement for both the scenarios will be the same. Okay, so let me shift this. Yeah, now how will you do for the C part? Yeah, we will equate the displacement covered for the total. Now I am considering it will overtake at a time t. So the car will, the displacement of the car will be equals to the displacement of the police car. So I don't know when they will overtake, right? But they are not overtaking in the 10 second because the distance is now. So we can say that the time will be greater than 10 second, that is for sure. So use your common sense, this will be 21 times t equals to the displacement for first 8 second is 128 that we have already calculated, plus speed into time. Now t minus 8, why? Because the first 8 second it is accelerating, so we have already taken the displacement. So the total time minus 8 will be the displacement covered with the speed of 32. Okay, so solving for t, you will get 11.63 second, which I can say t is equals to 12 second. So this will be your answer for the C part. Okay. Okay, pause the video and solve for question number 4. There are two balls starting out to the right with a constant velocity of 5 and 4. So let us say this is 4 meter per second. This is 5 meter per second. Now the slower balls start first and the other 4 seconds later. So this will go, and after 4 seconds this will start. Determine the position of the ball when they meet. Okay, so let us assume they meet at this point. Okay, so when they meet, I can say the displacement is same for both the ball, right? And we have to find out this displacement only. So what I can do is, I can simply say that, let us say the ball covers for the first ball, after the first ball it takes time t. So this ball has covered a distance in t minus 4 seconds because it started its motion after 4 seconds. So if I assume this ball started, slower ball takes t time to reach at this position, the 5 meter per second ball will reach in t minus 4 seconds, right? And they are moving with same, so displacement of the first ball will be equals to the displacement of the second ball. So first let us find out the time, and using the time we can find out the displacement. Okay. So first is V4 into t, and the second will be 5 into t minus 4. So 4t is equals to 5t minus 20. So 20 is the time in seconds. Now you can simply say that for S you can say 4 into 20, which is 80 meter. So simply the displacement or the position where the balls meet is 80 meters. Now the MCQs for paper 1 now. Just pause and solve. Okay. So here what we can say is, let us say after what is the distance traveled and the speed of the car was v by 2. So let us say the speed of the car at this position is v. So it covers a distance of, let us say the car covers a distance at this position, let us say it is d, right? And started from rest, so u is 0, let us say acceleration is a. So what I can use is, I can say v square is equals to u is 0 plus 2a into d. So acceleration will be v square by 2d, right? And this is constant. Now at, let us say somewhere it may be v by 2 might be somewhere here, let us say. So we have to find out this, let us say d dash. So what will be this d dash? So again v by 2 whole square equals to u square is 0 plus 2 into, now a is v square by 2d. I am using this into d dash, right? So solve this. V square by 4 is equals to 2 times of v square upon 2d times d dash. 2 gets cancelled, v square get cancelled. So d dash will be equals to d by 4. Simple. So option C is the right answer. Okay. Now pause for question number 2. Yeah. Now make sure that whenever you are using the suvat equation, these all equations are only and only applicable when your acceleration is constant. Now acceleration is a vector quantity. When I say acceleration is constant, I mean to say that both the magnitude and your direction should not change. So only option C, constant magnitude, constant direction. Rest all are incorrect, right? Now again you can solve for question number 3. Just pause it and solve. Yeah. So here the body is starting from rest again, and constant force means acceleration is constant, right? Everybody knows that force is equals to mass time acceleration. Mass is not changing. If force is constant, then acceleration has to be constant. So we have to find out the speed is v after covering a distance of d. The speed of the body when the distance is d by 2 from initial position. Again you have to find out the acceleration. V square equals to u square plus 2as. S is here d. U is 0. So I can say a is equals to v square upon 2d. Similarly, when the displacement is d by 2, assuming the speed is v dash, so d by 2 will be here. Assuming at this position the speed is v dash, and that is what we have to find out. So v dash square is equals to u is 0 plus 2a. Now I am using a as v square upon 2d times, now distance is d by 2. So this d and this d gets cancelled, this 2 and this 2 gets cancelled. So v dash square is v square by 2, or you can say, or what we can say is v dash is equals to v upon root 2, right? So option C is the right answer. So that's all from my side for this particular video, where we discuss about the suvat equations. If you have any doubt, just comment below. You can download the worksheet as well as the marking scheme for this video. The link is given in the description. Please share so that it reaches to the masses and it gives me a motivation to make more and more videos. Thank you for this session. See you in the next video. Keep learning. Bye-bye.